In this video, we are going to perform secondary injection tests on the TAPCON 230 basic device to verify that the automatic control is functioning correctly and to observe, in real time, how its key parameters respond. For this purpose, we will use only the main screen of both the web HMI and the local HMI interface. It will not be necessary to open any additional menus, as this main view provides all the essential information to monitor the regulator's behavior. In this test, we will not use an actual tap position feedback, since we will simulate the response by manually adjusting the voltage using a secondary injection device. Let's begin the injection. On the left side of both screens, we will see the electrical values measured by the TAPCON in real time. Next to them, there is a dynamic graph showing the voltage set point, the upper and lower bandwidth limits, and the current measured value. This visual representation allows us to quickly identify whether the voltage is within the acceptable range or if it has exceeded the defined limits. Now, I will lower the voltage to move it outside the bandwidth and trigger the T1 delay timer. On the arrows located at the right edge of the screen, we'll see a progress bar representing the countdown of the T1 delay time. If the deviation persists throughout the entire configured duration, the TAPCON will automatically send a command to adjust the tap changer position. This behavior is part of the setpoint control logic and helps avoid unnecessary actions due to brief or unstable voltage fluctuations. Once the T1 delay has completed, I will increase the voltage again, but still keep it outside the bandwidth, in order to observe the T2 delay in action. In this scenario, the system detects that multiple actions are needed to correct the deviation, so the T2 timer is activated as the interval between consecutive commands, or equivalently in this test, as long as the voltage remains outside the bandwidth. We will now see the T2 timer begin to count, and once it completes, another control pulse is sent if the deviation is still present. It's important to note that T2 only takes effect after T1 has completed, and only if more than one tap change is required to return to the desired range. Now, I'll adjust the voltage so that it falls back within the bandwidth. We'll see that the T2 countdown stops automatically, since the system no longer requires any action. Now, I will create a new deviation to verify that the TAPCON correctly restarts the T1 timer under a new out-of-setpoint condition. If we wait a few seconds and then increase the voltage back within the bandwidth, we can see that the T1 delay bar resumes counting until it reaches the configured value. Let's repeat the previous process. We move outside the lower bandwidth limit, wait a few seconds, and then re-enter the range. Now, before T1 reaches its full value, I'll quickly leave the bandwidth again, and we'll see that the delay resumes from where it was left. Finally, if I now increase the voltage beyond the upper limit, the T1 delay starts again, but now from its maximum value. With this, we have confirmed that the automatic control logic is working correctly, respecting the logic defined by the T1 and T2 delays, and visually displaying each step of the control process in real time. This main view is an extremely useful tool for commissioning tests, parameter validation, and operational diagnostics. This concludes the video. In the next session, I will explain how electrical quantities are displayed correctly based on the transformer ratio configuration and the selected connection type in the system.